So the topic, as mentioned, is quality evaluation. There are two domains actually in this presentation. One domain is related to ethics and ill practices actually, which are cropping up day by day, which have been happening in past as well. But so that is one aspect. And the another aspect is the quality assessment. And what are the anomalies in quality assessment, that also will look into. So these are the two aspects that will be discussing. Now, ethics in research and publication.
Sorry for interruption. You just press F5 full screen. सर फुल स्क्रीन कर दीजिए स्लाइड को.
सर ट्राई कर दीजिए. उसमें एक प्रॉब्लम था तो प्रवीण એટલા માટે.
तभी क्या होता है, अगर फुल स्क्रीन करते हैं ना तो वो
अच्छा
वो नहीं करता. फिर आई विल
ट्राई. ठीक है. हाँ हो गया सर. हो गया सर.
हो गया.
ओके थैंक यू सर.
यस थैंक यू. So when I was told that this is the combination of all faculty and the PhD students who are going to join in their respective faculties, range of different disciplines and range of different faculties. I will try, and I have tried to bring it to the normal level, so that rather than going into depth of the life sciences, I would try my level best to cover so that it can be normalized for each and every one of you. Now, basic format of the objectivity. When you plan for a research can be for a degree, research can be a project, research can be non-degree programs. Okay, and basically research. When you have research in mind, then what are the different kinds of formats of research? Okay, kinds of research. I have tried to just categorize some of them here. You can see. There are different kinds of research formats actually. For example, some research are survey type of research. Means just survey are to find out distribution of a trend, or the availability of informations, or prevailing patterns relating to societal traits. For example, population, education, literacy, or the status of nutrients, malnutrition, and so on, and also occurrence of a disease, for example, pandemic or endemic. Similarly, these categories can also be in particular reference to living system. For example, animals, plants, bacteria. There are different aspects: their metabolism, their genomes, their information processing system. So similar things can be percolated into living systems as well. Second category, research can be exploratory and observational. Means your purpose is simply to explore certain things or to observe certain things. For example, particularly in biological sciences, you take any biological systems, plants, animals, or bacteria. You do something, you get something. This is also a kind of research, but that is just the beginning of the research. That is not the. That is just, I would call it as an observation, because in living system, you treat the living system in response to certain factors, internal factors, external factors. They will respond in some ways, and you are simply observing the way they are responding. That is observation. Then asking a question. Are you following a question? Are you asking a question either with respect to social science, either with respect to languages, either with respect to life sciences? Are you following a question? Are you following a hypothesis? Then you have to. Then is an exploratory and investigative type of research. Means you are after certain answers to a question that you have in mind. Not simply observation, not simply observation, but your objective is that you have that particular question in mind for which you do such experiment, you observe and you draw inferences, and then either you find the answer or you don't find the answer. Okay? Then another kind of objective can be validation and confirmation of the facts. Validation is there are certain observations, certain facts, um, certain hypotheses, certain speculations, which are known to you, or you have observed, or you have created yourself, or from somewhere else. They are simply observation. They are simply speculation. They are simply hypotheses or hypothetical viewpoints. Confirmation of those hypotheses, confirmation of speculation, confirmation of those observations. That is validation and confirmation of the facts and observations. Okay? And based on that, inventions, theories, and principles are created. Based on this, the theories are created, hypotheses are validated, the principles of certain social sciences principle. The principles are not only in life sciences, in social sciences, also there are different kinds of principles related to society, related to anthropology, related to human movements, like that. And inventions. Sometimes inventions are accidental. There are many examples in science. For example, discovery of antibiotic. And even those who are not from science, they would perhaps have come to know the discovery of penicillin, 100, nearly 100, the first antibiotic, or discovery of any molecule which can inhibit the pathogens. 100 years ago, nearly 100 years, or maybe 90 years, it was accidental. It was not meant. It was not planned. But you can see the discovery which changed the face of the whole world of medicine. Okay. Similarly, there can be many other examples in physical sciences, in chemical sciences, in biological sciences. Okay. Now, some more ideas. If you are planning for a research, then where do we start? Where do you start? Where to begin with? Any research, any exploration, any investigation, any question that you are pursuing or following, you start with conceiving the ideas. You must have idea. Before, without idea, what to do, where to go, how to pursue. Okay, so these ideas can be original. These ideas can be already well established. These ideas can be based on existing knowledge in different forms. Or these ideas can be offshoot of already known ideas and knowledge. Okay, there can be different categories. Now, that's where the ethics comes into the picture. We'll see designing. Then next thing, once you conceive the idea, which question you're following, what do you want to know? Then आप किसी बीच में हुई स्थिति नहीं, आप एक बार बताओ। So conceiving the idea is to begin with. Then once you have conceived the idea, then designing the experiment. What would be the scientific way of following this? What would be the scientific way of following this? Then you have to go for research methodology in every discipline, in natural sciences, in social sciences, in linguistics, in management, in every discipline of the knowledge. And then after conducting the experiment, to go for observation. Observation and data analysis. So observation, collecting the data, analysis of the data, and based on this analysis, conclusion and inferences are drawn. And finally, at the end, you need to cite work that you have taken from somebody else work and cite that work. If you do not, and that's the lack of ethics, and that's where we are lacking. That we should acknowledge, we should cite the work that we have used in our methods, we have used in our discussion, we have used in drawing the conclusions. So that is the ethics in acknowledging, citing others' work. Now, proceeding further, retrieving the information, and just relating to the previous statement, retrieving the information, because if you are using somebody else's information present or available in the literature or databases, different kinds of retrieve from certain informations are available in public domain, certain informations are not available in public domain. Now, then using the information generated and published by others, that is retrieving the information and citing for your own purpose. Then plagiarism. What is plagiarism? I think by now you all are aware that plagiarism is something which is a mistake, or copying some from somewhere, copying something directly and without knowing that person, without letting that person know, without getting of that person or publisher. That is so there can be different categories. Some plagiarism categories means that the data can be taken from somewhere else, the words and phrases can be taken, the passages can be taken, or even ideas and concepts can be taken from different places where you need to take permission, but actually you have not taken it. So that is the lack of ethics, and that's why I think you are aware that when you go to submit a thesis, you go to submit a paper or transcript, you have to go for plagiarism. There is a minimum level. There is a bottom line above which your plagiarism should not exceed. And then in context of plagiarism, we need to take permission from the authors or publishers or anybody which posts that information for that particular item. So you need to take permission, you need to acknowledge, and you need to cite it. Different manners. This is one of the reference which I can share with you. It's not very huge document, but it can give you some information relating to different aspects of ethics that elsewhere. Now, proceeding further into the assessment of research quality, research publications and assessment. See, there are different ways to assess your work. Not necessarily judge somebody's work, but assessment is a better term actually. Judging somebody is different. Assessing somebody is different. Judging somebody means you may have a negativity in yourself, but assessment, negative, positive things both can be in that. So I mean the different words used in different contexts at different times, but they reflect different meanings and different waves actually. Now, putting all the disciplines together, everything as you are reflecting on all disciplines, science, different disciplines, physics, chemistry, mathematics, life sciences, social sciences, then languages, Hindi, English, then management, commerce, social sciences, every discipline is covered. So there is a wide variation. So different disciplines have different means and different criteria for the evaluation. One general thing, for example, those working in science, for example, we are working in life sciences, those who are working in social languages, their criteria of reflecting their outcome cannot be directly correlated with the same as for life science. Their journals have different, we'll see that different variety of journals, different things that are that are different in different disciplines. Okay, so there's a wide variation of the mode of assessment, and that depends on the judgment, on the assessment, and on the outcome of the research. Okay, okay? And there are different levels of research outputs, different levels and different ways the research is reflected. What are different ways? Publication is one. The frequency of publication is another thing. How many publications you have? How many research papers you have? 1 year, in 6 months, or 2 years? And what is the quality of publications? And again, I would like to read, because we are referring to all disciplines in science, the research publications, research articles are which is most. Whereas in languages, I have seen that writing books is very common. Similarly, in social sciences, there are different ways of reflecting their outcome or presenting their outcome. There are different ways. Okay. Now, another reason of variability, is lack of interest. Even just talking about the life sciences. In life sciences, there is a huge variability. You have zoology, you have botany, microbiology, you have pharmaceutical sciences, and you have different other forms of life sciences. Now, environmental sciences. So we'll see that mode of assessment, it cannot be same for all disciplines, even in life science. Even in life science. So one of the reasons you find that some persons or some groups, they do not have much outcome. The reasons can be lack of interest. They may not believe that publications are the right criteria. Their thinking is different. Okay, their objectivity is different. The research objectivity is different. As at the beginning we cited, that objectivity is different, and also the types of publications. I think previously also we mentioned that. What are the different kinds of publications that we come across? Taking all together, so there book chapters are there. Means there are edited books in which different authors contribute to it, and a particular theme there is a book, and in that book, different persons area. The review articles there, then research papers, then comments, criticism, and letters to editors. There are different categories of papers. Then types and quality of the journals. Okay, within the journals, there are different types. For example, as well as in the books also, there are textbooks, there are references, there are edited books. As mentioned in the previous point, there are journals, there are review journals. Okay? These are the different categories. Now we are coming slowly and slowly to the assessment, and where in the assessment the ethics comes into the picture. Where there is a violation of ethics, or there is a unwilling biasness, actually. Unwilling. You don't intend to create unethical trades, but actually it happens. Some of the examples we'll see. We'll see as we go ahead. Citation, as we are all aware, a citation, it began, I think, more than 100 years ago, in 19th century, 1873, and it was cited by Shepherd. And initially, it was used as a tool for legal citations, judgments in the courts. The citations were used. And later on, now, the modern time, It's a whole science actually, the Institute of Scientific Information. Whole science of citation. That is the whole science in its own right. Citation is you are retrieving some information, you are using that information which is available in public domain or may not be available in public domain. So first you can retrieve it either with the permission or without the permission of the person. That is retrieval of the information. Now, when this citation came into existence in very structured form, it started like this. First sciences, then social sciences, then humanities. Usefulness of citation, more relevant, began first in science, physics, particularly natural physics, chemistry, biology, and mathematics, and sciences. Then it was used in sciences and also now. So the purpose of the citation, the first is retrieval of the information. Basic purpose is retrieval of the information. It initiated with that objective. The citation, the whole story or whole history of citation, and with driver. You want to have certain informations. You want to have certain informations for different purposes. Even in business, you need some informations. In developing technology, you need informations. In selling certain goods, you need informations. So retrieving the informations. Then this citation was further extended for the purpose of research evaluation. Initially, it was not meant to. Initially, it was not meant to evaluate, but later on, it became the basis of research evaluation, and then consequently, it became the basis of different indexes, and some of these we'll discuss that, for example, impact factor, for example, H index, and so on. So the basis of the calculation is citation. Okay, we'll see. Now, this is what we have just discussed, retrieval purpose. Initially, it was retrieval, then now then it started in research evaluation, and then in calculating the indexes, for example, the perfect. Now, comparing the citation. Now, if we compare, this is one example, that if you compare Nobel Prize winning, particularly in science, as I mentioned, that criteria in different disciplines can be different. Now, this example I'm citing here is particularly from. Now, if you compare a Nobel Prize winning scientist, and non-Nobel Prize winning scientists, we compare with them, the difference in number of publications can be, for example, 5 times. The Nobel Prize winning scientists may be publishing maybe 5 times more publications, or 5 times, around 5 times, but the citation of their work is 30 to 50 times. Okay, number of publication is only 5 times or around 5 times, but the citation is 32. So it is the citation of the work that matters. No matter how many papers you. That's why today, you go for interview, okay, they will ask that how many publications, and then you will say, then they will ask you what is citation. Okay, citation, and means suppose you have 20 publications, what is the citation? Okay, and sometimes there is embarrassing situation in the sense that if you say that you have published 20 papers from your PhD, for example, we have faced these situations, 20 papers from your PhD, and then next question will come, what is the total citation? What is the impact factor? And then if it is not up to the mark, then that means the quality of your results are below normal. Okay. Now, between, if you have any question, please feel free to ask. So far, whatever I have discussed, any question from the audience, please feel free to ask. Anybody would like to ask anything? Anybody would like to ask? Please feel free to ask in between as well. At the end, we'll give enough time. But I wish that if you have any question, anything that you have in mind, I wish that you ask. Okay? Okay. Then is impact factor. Now, impact factor, usually it is associated with the journal in which you publish. Okay? Journal in which you publish. Okay? Different journals have different impact factors. The basis of calculating the impact factor is the citation. Okay? Means the papers published in that journal, how much citation has been attracted by those papers published in that journal. Okay. Now that is the basis of impact factor, and that is impact factor of a journal. Now, another thing that is interesting and important, and I think you'll be know it, that impact factor actually is more reflecting on the journal rather than the person who has published in that journal. You understand this thing? Of course, indirectly we feel good. We take pride in the fact that we have published in impact factor journals. But actually, the primary credit is not yours. The primary credit is of the journal. And we'll see that reason. But again, I wish to tell you that please don't get demoralized. You must aim for high impact factor journals. It is your credit. What we're discussing here is some more technical point. So I don't mean to say that publishing in good impact factor journal is a discredit. No, I'm not saying that. Publishing in good journal is always interesting, is always credit to you, but there are certain technicality which we are going to discuss. So the impact factor is based on average number of citations to all articles together. Suppose there are 20 articles in that journal, then impact factor is not based on one article, but it's based on average article. Okay, average impact, average citation. Okay, and that's why I mentioned that the primary credit is not the authors who have contributed, but it's a overall, because you are averaging. There is the average now. Okay. Now, but I still want to say that journals with high impact factor, they are more important. You should go for them, and you should not be discouraged by this discussion that the primary credit is not yours. It is not the discouragement, but it's a scientific fact actually on the basis of which the impact factor is calculated. Okay. Now, there are many ways. Different journals have different impact factors. Please don't believe them. Sometimes unknown journals, they write impact factor very high impact factor. Never heard of that journal. Never heard of that publisher. Impact factor 5, 6, 7, 8, 9. They have different ways, different. So please do not get carried away with those numbers. The credible impact factor which is taken into account all over the world is Thomson-Reuters and Thomson-Reuters Corporation, and that's why the Thomson-Reuters impact factor of any journal. Okay, Thomson Corporation, and then it merged with Reuters, and now it's Thomson-Reuters. Oh, a brief idea how the impact factor is actually calculated. It's very because it's a number. A journal has a number. For example, impact factor of 5, impact factor of 5.8, 2.1, 1.5. It's a number. It's a number. Then there must be a means to calculate that number. There must be a means to reach to that number. What is the basis to reach that number? Arbitrary. It's not just any number you put. So that's why I mentioned if any journal put any number, that is mistake. That is lack of ethics, So don't go for those journals. I always tell our students that don't go for the numbers. If you have good data, try to publish in good journals. If you have good data, don't go for 5 publications. Get only 2 publications. Integrate your data, conclude those data into a concept, and then you have an opportunity to publish. But if you are attracted by the numbers, for example, many of you are attracted that, oh, I have this much data, then why should I compromise with only 2 papers? Why not to go for 5 papers? But you should take it. You should also take into consideration if you publish 5 papers, then what will be the quality of those papers? That will be only observational research. You cannot conclude any concept. You cannot reach to any conclusion. You cannot reach to any hypothesis. And that's why you would not be able to listen. Okay. Now, briefly, I think please have a look on this. That impact factor is a numerical value. Impact factor of a journal in a particular year is based on the previous 2 years actually. Okay, here, for example, if you calculate the impact factor of a journal in 2008, then you have to take all papers published in 2006 and 7 and cited in 2008. Okay, and that is impact factor. The papers published in previous 2 years and cited in that particular year in which you are calculating the impact factor. This is the example. A upon B. Calculation is A upon B. Then what is the A? A is the number of times article published in the previous 2 years. For example, if you are calculating the impact factor of a journal of 2008, then you have to find out the number of articles published in 2006 and 7 and cited in 2008. For example, 30 articles published in 2006 and 2007. 30 articles. 30 articles. How many times were referred in 2008? That is A. Okay? A divided by B. B is the total number of citable items. And that's where the ethics comes into the picture. We'll discuss that. The ethics in publication, ethics in journals, misdeed of the journals, some items that we'll discuss. Citable items. What? A is the number of times the articles published in 2006 and 7 or the previous 2 years have been cited in that particular year, for example, in this case. Then 8 divided by B, total citable items. Total citable items, and that is the impact factor of 2008. A upon. Any question from anyone, please? If you have any question regarding this calculation, then please feel free to come. Please feel free. Okay. No question. I wish that some of you will ask questions. Okay. I intend to have this session more interactive. Okay. Nobody would like to ask any question? Praveen, I hope that you are listening. Praveen, are you there? Praveen?
Yes, sir. Yes, sir. Yes, sir.
I hope that they are listening. I wish that some of them they will interact and not necessarily that at the end of the session. We'll have at the end of session also, but in between also, if you have any question, please feel free.
Yeah, definitely, sir. But at last, they are asking the question if they have a doubt. No doubt.
Okay.
In between, they are also raise the question. Okay, no problem.
Okay. So we'll go ahead.
Yes.
So now the point that I mentioned in the beginning, why impact factor is not so credible parameter. Why? The reason we'll see. The impact factor of a journal is valid, should be valid within a particular domain. Within a particular domain. For example, a journal published in clinical science, the impact factor of a journal in clinical science should not be compared with a journal which is publishing social sciences, which is publishing any case history in management, which is publishing language development or the manner in which languages have been evolved. Different criteria, different. I mean, it's just like mixing apple and oranges. Okay, you cannot mix apple and bananas. If you have to compare, you have to compare different varieties of bananas, different varieties of oranges, different varieties of apple. Okay, you understand? So that is the comparison would be valid within a certain domain, even within life sciences. I'll just give example within life sciences, science, ecology, fundamental genetics, and the environmental sciences. Varying criteria, and this citation actually we'll see in a minute. It directly relates to the readership. That what is how many people are going to read this journal? More people will read means more people will cite your work. So readership is very important. Okay, and that will decide the citation. Okay. So highly disciplined oriented. This should be confined to within that particular domain. Could not be reproduced in an independent audit. It refers to the average number of citations per paper, not, as I mentioned in the beginning, that it's not just individual paper, but it's average citations, average citations, and that is the basis of the not individual. It's average. It's not even addition. It's an average citation. So somebody has very high citation. Somebody has either no citation or very low citation. Okay, but same journal, same volume, same issue. You have this scenario. For example, your paper has 100 citations. My paper has only 10. But the same volume, same paper. So, and the impact factor of journal is the same. So this thing is not going to be distinguished by the impact factor. Okay. And another thing is self-citation. Most of us tend to cite our own work. If it is relevant, no. I mean, there is nothing wrong. We should not be ashamed to cite our own work. Sometimes irrelevant citation occurs. And journals, many journals have different policies and ill-framed policies actually. And that's where ethics comes into picture. Many journals have such policies which increase the citation. Increase the citation, and if increase citation is increase the impact factor and increase the credit of that particular. Okay, that is the ethical issues. With more precise example, we'll see in a minute. Now, these are some examples that how impact factor is actually affected. Okay, larger percentage of review articles. Now, if the journal publishes more number of review papers, more number of methods, more number of such things which is going to be asked any software, then more and more people will use it. More and more people will use it, more and more citations. And this policy, they increase the number of review papers, increase the number of methods, increase the number of softwares this we use commonly, then certainly the citable items is going to increase. The citable items. One example is given in one particular example. I do not have any example from social sciences or languages, but this is the example from natural science. In physics, act of crystallography, and this is the example in 1 year you see the impact factor, how did it increase impact factor? In 2008, it was 2. It increased to 49. Yeah, unbelievable. How did it happen? And this number is in more than nature and science. 49. How did it happen? This is one example. In that particular paper, in that year, crystal structure of molecule was determined, and because in that crystal structure, a particular phrase software was used, and that software was cited so frequently, name of the software or name of that phrase was used so frequently that it increased the citation so high, and that is the result of this. Okay. Now, incorrect application of impact factor, or you can associate with the ethics, ethical issues can crop into it. That and because of these issues, for particular decisions, for example, recruitments, impact factor is not taken in many countries, as well as in North America, USA, Canada. They have different other criteria. We'll see what is other criteria. This is the point that you mentioned. Let's go to the point number 2. A small number of publications are cited much more than the majority. This is what I have cited. Just a moment ago, I cited that suppose there are 20 papers published in that volume, that issue, for example, or entire year, for example. So what is the scenario? This is the example of nature actually. This is the example of nature. 90% of the nature's impact factor is contributed by only 25% publications. So the 90% of the nature's impact factor is due to only 25% of the papers published in nature. What about remaining 75%? Okay, so the 10% contribution in the impact factor is by 75% of the papers published in nature. Okay, you see the scenario, and that's what I was trying to mention in the beginning, that why impact factor is more reflecting on the journal rather than your individual article published in that journal. Okay, so as a result, what is the scenario? There is an underestimation of the most cited articles. Means those 25% articles which have contributed 90% to the impact factor, they are undercited, or they are underestimated. Not undercited, but underestimated. Their weightage is severely underestimated. On the contrary, there is an exaggeration of 75%, meaning so 25% weightage is reduced, 75 weightage is enhanced. You see, this is the scenario, this is the case. That's why individual articles versus journal's reputation. Impact factor reflects primarily on the journal's reputation rather than individual. I hope this point is clear. If still there is any point or anybody would like to ask, I'll be clear further. Now, there are certain ethical which have cropped time to time. For example, this is a research paper published in Science, 2013. And what does it say? That it's a San Francisco Declaration on Research Assessment. Now, in that paper, DORA, it's a DORA and the Declaration on Research Assessment. They do not take impact factor as a credible parameter. They do not consider impact factor as a credible parameter to assess scientists' contribution, to hire somebody, or to decide about granting a research grant. Okay. Now, another thing related to misuse of the journal impact. Now, what is the scenario? People are rushing after high impact factor journals. High impact factor journals means those journals in which more and more number of people are working, because high impact factor means high citation. High citation will come with more and more people. More and more people means crowded area. For example, clinical sciences is one of them. Okay, who nowadays you just out of 200 or 300, 250 among you in life sciences, who would be interested to to work in classical ecology? Who would be interested in classical genetics? Who would be interested in classical biochemistry? Who would be interested to follow the regulation of operon model in bacteria? Okay, anybody would be interested, but most of you would be interested to go for cloning of a gene, microbiome, and then recombinant proteins, and like these areas. Okay, so this mad rush caused due to high impact factor general syndrome. This is, I mean, this is just my own creation. High impact factor general syndrome. What it is leading to? It is actually it is leading. In a way, it's in a third point. It leads to this. It's blocking the innovation. It's blocking the innovation. What does it mean? Innovation. Sorry, innovation means most people will go will decide to go to areas which are already crowded. Will work in lesser crowded areas or lesser attended areas. Means that you are blocking the innovation, because already highly populated such areas exist, which is attracting more and more young generation, younger people. They will be attracted to work in that areas. So in a way, it's blocking the innovation. These are some unethical issues. Time to time, they have cropped into it. That how the citation have been severed, actually, how it has been manipulated. And these are some of the examples in different. These examples do not mean that these are the only persons, but these are the examples which have appeared in different, for example, in Nature, few years ago, where a particular biophysicist who was a reviewer in a particular journal, and you know the reviewer's job. When you submit a paper, it is sent to a reviewer. Journal will send to a reviewer. Reviewer will assess your paper, and when reviewer asks you to cite his own papers so frequently, even though it's not related to, then that is unethical. Okay, and that has happened in many cases. This is one example. One example, and the second example is in the theoretical biology, Journal of Theoretical Biology, where a particular editor was banned from the team because of the misconduct of the highest order. Now, what is shown in this slide actually is no more first author, no more. But nowadays there is a multidisciplinary research. Multidisciplinary research means more number of people involved in that research. More number of people involved in that research. But the question comes, who will be the first author? Okay. So first author. So if there are 20 people, 10 people, then who will be first author? That is the question. So in some journals, they have removed this first author, second author things. Means there is no first author, there is no second author. All authors are equal, and that will allow people to participate in participating research or in interdisciplinary research. Otherwise, people will have this feeling that if we participate, then somebody will take the credit. somebody will be the first author. Then what will happen? If this first, second, and third authorship is removed, then then people will be tempted to join the multidisciplinary research team. The another issue which is relevant to all of us, whether it's social science or science, is about the language, because language of the papers, books, or any report which is being published, and there is a trend which has been analyzed, and that trend has been analyzed by a very prominent scientist at IISc Bangalore, Indian Institute of Science Bangalore, E. Balasubramaniam, and this appeared in a particular newspaper and also in an article. And what does it say? That research papers are getting difficult to read. Means the language of research papers are time. With time it's getting difficult. Complexity, the language and comprehension is getting difficult, getting more complex actually. And they have compared with those days of Charles Darwin and those days, because in those days it was not that science was only meant for people who work in science. Science was a philosophy, and philosophy, science and philosophy, it was difficult to segregate actually. So anything which is published or which is hypothesized, for example, Charles Darwin's theory of evolution, that was not meant for only those who work in science, but for everyone else. And that's why the language in those days was very simple, and so that people can understand, can read, and can comprehend. So readability is, but slowly and slowly, this language complexity has increased, and nowadays many journals, our scientific writings are difficult to understand. And this is particularly in cases where the language is not, your first language is not English. Okay, India is still much better in such a situation, but imagine those countries, for example, Africa, and the Taiwan and Thailand and other countries where the English is not at the level that we have. Okay, so this is one trend which has appeared, which is appearing, and one of the reasons, I don't know how much true. One of the reasons that the scientific community actually, and that's why when you publish a paper, they ask you, they expect you to write your abstract in most simple form, without complexity of the complex data, so that this abstract can be read by those who do not work in that particular area. You are expected to write the abstract in such a cohesive and very lucid manner, so that it can be understood by a person who is not a scientist or who is not working in your field. So some people say that language is getting complex, so that less and less people are reading it, so that more and more people are prevented to read it. I don't know whether it's to which extent this logic is true, but certainly this is the trend which depicts that complexity of language from the days of, for example, Charles Darwin. And these days, on the origin of life, when people were easily able to understand what he wanted to say, what he wrote, what he did, and what he wanted to say. Now, we have seen what is impact factor, how it is calculated, what are the merits, what are the demerits, why people do not take it as a credible parameter to judge, to assess, to decide recruitments, to decide the project grants, to decide a membership. We have seen that. Now, H index is another parameter. Some of the points which we discuss as a negative point or demerits in impact factor have been answered in this. Okay, What is H index? H index, it takes into account of the productivity and impact of the published work both. Productivity means over a period of time. For example, 5 years, 10 years, 20 years. And it also tells about, suppose a person has worked 20 years ago, 15 years ago, and last 5 years, the person has been silent or dormant. So this thing, so productivity and impact of a research and its continuity, and that is reflected in terms of H index. And the productivity and impact of a scientist, of a group of scientists, of a department, of a university, and the umbrella can be as large as you want. And why H index? What is H index? As many of you might be knowing, it was initiated by a scientist, George S. Hersh, physicist, and is of as Hersh index or Hersh number was based on his name. Now this plot actually, H index plot, I think you can easily see this plot, and if you just follow this cursor on this axis is a number of papers here, and this is the citations. Large number of papers you may have, but you can see papers with high citations are very limited. You can see limited. While most of papers published by a person or group, it has low citations. This is the trend which is reflected. So what is H index? Into this plot, you can see H index is equal to number of papers is equal to citations. I'll explain this by taking an example. What is H index? S, for example, your H index is 20. Okay. What does it mean? It means that at least 20 of your research papers have a minimum of 20 citations. That's why you see here citations. For example, 20 citations, 20 research papers, and 20 H index. So if your H index is 20, means at least 20 of your research papers have a minimum of 20 citations. It can be 100, it can be 80, it can be 60, but minimum of 20. So H index is a number equal to the number of papers having that minimum number of citation. Okay. This example, I think it is your H index is 20. It means that you have minimum of 20 research papers, and those 20 research papers have a minimum of 20 citations. That is H index. Okay. Now, certain points have been taken into account, and you can see that scientists working in the same field, again the same thing is, there is a domain specific. Scientists working in social sciences, scientists working in physics, scientists working in clinical sciences cannot be compared because their domain is different, their readability is different, their readership is different, and the number of people working in that domain is different. Okay, that's why this must be compared within certain domain itself. And as we have seen, the H index is directly depends on the number of highly cited papers. Larger the number of highly cited papers, larger the number of your H index. Okay. And in other words, you can say highly cited articles will contribute to the H index. Okay. And the productivity. The next point relates to productivity means H index will grow with your age, rather academic age. Why I mentioned how active one has been, academic age, and how active you have been, and these are some criteria I can see. that different bodies, they have different range of H-index to take decision, or at least to take some help in deciding whether a person should be promoted to professor, whether should be promoted to a membership, or awarded a fellowship, or the person should be part of any governing body in the government. This is what we've already discussed. Certain demerits again exist. For example, number of authors. Suppose in one research paper, there are multiple authors. So everyone will be using the same H-index. No, the H-index will not distinguish between between these two scenarios. For example, in one research paper there are 2 authors. In the research paper there are 5 authors. In other research paper there are 20 authors. So that distinction will not take place, and it does not account for the typical number of citation in different fields. This is a highly domain specific, or is a specific domain where people working in different fields cannot and should not be compared. And the point is that any kind of citation or any kind of description of that particular person, even in bad light, suppose anybody has done any misdeed, or somebody has stolen data from someone and published it. So even that will be discussed and described in journals, and that will be taken as your publicity, and that will be counted while computing the H-index. So the reference and citations made in negative context, for example, fraudulent or any plagiarism issue, that will also be taken into account, and that will add to the H-index. Another important point: the researcher in the same age group should be compared. Means a professor who has completed 20 years in the research career, and a student who is just going to join or who has spent 5 years in Ph.D. So the Ph.D. student just intern and completed 5 years, and a professor who has completed 20 years, they cannot be compared. Their H-index cannot be compared. Okay. Again, the same limitations as it was for the impact factor. Review articles. More, if you have published more review articles, your H-index will be higher. If you publish more methods, it's likely that your H-index will be high. If you have a self-citation, then that will also increase the H-index. These are some of the points which are also relevant in impact factor and is still relevant in H-index. Okay. Research, and Google, these are the most commonly used platforms. And the Web of Science, certain number of journals they have in different fields. So because people are here in this gathering, people are from social sciences, arts, humanities. That's why I think these platforms are interesting and useful to all of them. And then Web of Science, this is most commonly used. Then the Web of Science, certain criteria, certain characteristic features, and you can generate your profile, individual profile. You can generate your year-wise profile. For example, published items in each year or citations in each year. These kind of information can be generated. And then Web of Science, it's multidisciplinary database, social sciences, life sciences, and then Scopus is another platform. Scopus, and then Google Scholar. Google Scholar, you can generate your own profile, and in Google Scholar, you can generate your own profile. For example, this is how you can get. This is how you get the profiling, the year-wise citation, then citation, H-index. Recently, just a few days ago, I just got it from and up to 2020. And these are the co-authors, most commonly occurring co-authors in my research papers. And the platform is ResearchGate, this kind of information can be generated. ResearchGate is another number, and this is the comparison of different platforms of science and Google Scholar and Scopus. And then finally, just I'll take 4 minutes.